Okay, good evening everyone. Let's talk about the problem in Web Assign where I have a wire and a coil. This is my coil. The coil is situated like this. This is your wire and this is your coil. It's like that. Okay, it's not around the wire, it's like this. Okay, so this is the situation here. And the question said the I is increasing. I is increasing. Okay, so before we tackle this question, let's try to remember what happens when we have a current carrying conductor. What is the magnetic field? So let's say my wire is carrying current I. This current is not increasing. This guy, the I is increasing. Okay, so I have I that is not increasing. What happens? I will have a magnetic field that goes around the wire, right? How will this look like in 3D? So let's say my pen is like this. Okay, like that. So the magnetic field will look like this. In anti-clockwise. So this will be my B, like that. Okay, this is if it's in 3D for this guy. Alright, so the magnetic field that is produced by the wire is in the anti-clockwise direction. So if I were to draw this like this, some people will say, okay, is it like actually flat behind the wire or is it going around the wire? So to not make people confused, people will label this as going into the page and this will go out of the page. Because why? Remember our right hand rule, when our I is going up, my magnetic field is going around the wire like that, which means that it is going into the page and it goes out of the page. So into the page, I will see the butt of an arrow. Out of the page, I will see the pointy part of the arrow. Remember the arrow like this. This is your pointy part. This is your butt. The butt of the arrow. Pointy part. I don't know what you call this, but I'm just gonna call it pointy part. The pointy part of the arrow and the butt part. So the butt part should look like this. Okay, but you only see this guy, so you only see it as an X. Okay, so this is when your wire is carrying I, but the I does not increase. So your magnetic field does not increase. It's just stable like that. Now what happens when we have a situation where our I increases? When our I increases, our magnetic field also increases, which means that we will get the rate of change in flux, which gives us induced EMF or current. Right? If you have watched chapter 20, you will know what I'm talking about. So if you have increasing I, you will have increasing B, you will have this guy, which is needed for induced current or EMF. Now, the question is asking you, what is the direction of induced I in the coil? Okay, forgive my writing. So let's draw the magnetic field of the wire. So as we know, using the right hand rule, my I goes up. My direction of current and my direction of magnetic field is like that, which means that my magnetic field goes into the page, into, and goes out of the page. Okay, I said when you have I in a wire, you will have B. What happens when you have I that is increasing? Your B will also increase. So let's say if your I is 10 ampere, your B will also be 10 proportional. Let's just say proportional. Okay, so your I will be proportional to your B, or your B is proportional to your I. But every time there is B inside on the right side, there will be B going out from the left side. even though your B increases from the increase in I, the B that goes into the right side is equal to the B going out of the left side. So every time you have an increase, both sides will have an increase as well, and they cancel out because the magnitude of this B is the same as the magnitude of this B. Remember, it's symmetrical. So let's put it here. It's symmetrical. So whatever that goes into my coil will be the same. Alamak, tak ada pula kat sini. Okay, so if I have like two lekuk kat situ, what do you call lekuk? If I have two thingy going here, I will have two thingy going out of here because it's symmetrical. Okay, so this is the same case. Going into the right side will be equal to going out of the left side. So the net flux is 0 because the B from here is cancelled out with the B from here. If my net flux is 0, my induced current is 0. Because remember, we need this to get induced EMF or current. And if my net flux is 0, my induced current will also be 0.